image resolution for remote sensing, and we said that there are 4 different types of image resolution when we talk about remote sensing. So what are those 4 different types of resolution? Yes, tell me one.
Spatial.
Spatial resolution, okay, first one. Second one, resolution of the image. There are 4 different types of resolution. He said the first one, spatial resolution.
Spatial.
No, that is the type of platform and sensor. No, I am talking about the resolution. Spatial, he said.
Something like
Spectral resolution, okay. The second one is the spectral resolution, okay. Third one, the time between 2 images of the same area, which is called as temporal resolution. And then the fourth one refers to the number of colors you can see, which refers to the radiometric resolution. So these are the 4 types of resolution when we talk about remote sensing images: spatial resolution, temporal resolution, spectral resolution, and radiometric resolution. Now here it's written Landsat images have resolution of 30 meters and Sentinel images have resolution of 10 meters. Now which resolution I am talking about? Is it temporal or is it spatial? Is it spectral? Is it radiometric?
spatial.
Spatial resolution means this 30 meters and 10 meters. I am talking about the pixel size. Okay, so when you talk about the pixel size of an image, you are talking about the spatial resolution. So which has a higher spatial resolution, Landsat or Sentinel? Is saying Sentinel has a higher spatial resolution.
No. Sentinel.
Sentinel is smaller the size of the pixel, higher is the spatial resolution. So Sentinel, the pixel size is small. That means you can see things more clearly as compared to Landsat. Okay. Then the second sentence you read: Landsat images have 11 bands and Sentinel images have 13 bands. So which resolution I am talking about? Spatial, temporal, spectral, or radiometric?
No, radio.
Huh? No, I am talking about spectral resolution. Spectral resolution refers to the number of bands which are there in an image. Band is what? Band is a range of wavelength for which the image has been acquired. So Landsat 8 and 9 they have 11 bands, whereas Sentinel 2, 3 they all have 13 bands. So I am talking about spectral resolution. So which has a higher spectral resolution, Landsat or Sentinel? Landsat has 11. More the number of bands, more is the spectral resolution. Sentinel has 13 bands. So Sentinel has a higher spectral resolution as compared to Landsat. Now read the last statement. Landsat image of an area can be obtained every 16 days, whereas Sentinel images of an area can be obtained every 5 days. So which kind of resolution I am talking about? Yeah? I am talking about the temporal resolution. Temporal resolution refers to the time gap. T for temporal, T for time. Remember like this if you cannot remember it in any other way. So temporal resolution refers to the time gap between 2 successive images of the same area. Now, which one has a higher temporal resolution, Landsat or Sentinel? I'm saying Sentinel has a higher spatial resolution, higher temporal resolution. Is it true? Or Landsat has a higher temporal resolution.
Yeah.
One is you are saying Sentinel, you are saying Landsat. Now fight with each other and tell me which is correct. Tell me all sitting at the back. Tell me which do you think? No, I'm not talking about the band. I am talking about the time. Time for Landsat. You have one image of Riyadh from Landsat today. The next image will be after 16 days. In Sentinel, you have one image of Riyadh today. Another image will be after 5 days. So, which one has a higher temporal resolution? Landsat or Sentinel? Sentinel is smaller the time gap, bigger is the temporal, higher is the temporal resolution. So, Sentinel images, they have, yes, you are right, no need to fight. So, Sentinel images have a higher temporal resolution because the time difference, if the time difference between two successive images are small, then that means the temporal resolution is high. If the time difference is large, then that means the temporal resolution is low. Okay. Now, if you are using a satellite image for observing the land resources, observing the earth, which kind of resolution you will be looking for? High spatial resolution or high temporal resolution? Means you want to see, say for example, you want to study the changes in land use in Riyadh. So to study the changes in land use in Riyadh, you will be looking for an image with a high spatial resolution or a high temporal resolution. High temporal means you need one image of Riyadh from today and another image after 5 days, and then you can compare the land use. So, but land use means you want to see where the area was barren and where now you have a building, or like you have an image from today from Riyadh. There is no what you call. Okay, Diriyah is not still under construction. It is not there. You take another image after 10 years, maybe it will be there. Everything will be constructed. So, how will you know whether you can see this Diriyah thing on the map or not? You need high spatial resolution or high temporal resolution? You need a high resolution. So which resolution? Temporal or spatial?
Temporal.
No, to see the thing on the map means whether you can see the King Saud University, whether you can see Morabba, whether you can see Neom, which kind of resolution you will look for? Spatial resolution. You will look for high spatial. The pixel size should be small. If the pixel size is low, then you don't know where is King Saud University. You can't see whether building College of Science is there or not there if the spatial resolution is low. So, to identify the things on the surface of the earth, you need images with a high spatial resolution. But on the other hand, if you have to see the changes in the land use, if you take one image of Riyadh from today, another image say from 5 months ago or 6 months ago, or maybe after 6 months, can you see change? Okay, you will see some change, but not a big change. If you have to see the big change, you see one image from today and another image say from 10 years ago. Then you can see what has changed in the city, how the city has grown. So for observing the land use of an area, you need images with high spatial resolution, but temporal resolution is not required. You can use images which are 5 years, 7 years separated. What about if you want to study the weather of an area, what kind of resolution will you be looking for? For understanding the weather, so you will be looking for low spatial resolution and high temporal resolution, or high spatial resolution and low temporal resolution. Temporal resolution should be high. That means you have one image of Riyadh or Saudi Arabia from today and another image after 10 days, or another image after half an hour. Half an hour. If you want to study the weather of an area, weather pattern of an area, you need to have images which have a very high temporal resolution. For weather satellite, you do not require images with high spatial resolution. This is important. I will ask in the exam. So, Once again, tell me what will be the answer for the first one. Read the first question and tell me what will be the answer. Landsat images have resolution of 30 meters. Sentinel images have resolution of 10 meters. So what kind of resolution I am talking about? Spatial, temporal, radiometric or temporal? What kind of resolution I am talking about in the first stage? Huh?
Spatial.
Spatial or temporal? Temporal? Spatial resolution, it will be in meters. Temporal resolution refers to time. Is 30 meter time or 30 meter size? Size. So size will refer to what? Spatial resolution. Okay. So in the first sentence, I am talking about the spatial resolution. What about the second sentence? What am I talking about?
Spectral.
Radiometric or spectral?
Spectral.
Bands. When you hear the term band refers to spectral resolution. Okay, I am talking about spectral resolution. What about the third line, third sentence? Landsat images of an area can be obtained every 16 days, whereas sentinel images can be acquired every 5 days. So this is temporal resolution. This refers to the time gap. Okay. So we discussed all this, okay. Weather satellites, they are, yes, you have any question?
Yes.
Yeah.
Can you give us an example for things that need high spectral resolution?
High spectral resolution, okay. For the spectral resolution, for example, you want to study the land surface temperature, okay. Temperature of the earth, difference between the temperature of the land and water. So in that case, you will need a spectral band in the thermal infrared region. If there is, like, if you go here, for example, here you have 3 satellites. One is NOAA ABHRR, the other one is Landsat, the third one is QuickBird. And I want to study the temperature difference in different parts of the city, or I want to understand the temperature difference between land and water. So to see the temperature, I have to look in the thermal infrared region. Now look at this and tell me which will be. These bands are showing the spectral resolution. So if I have to study the temperature difference in different parts of the Earth's surface, which satellite will be better? The first one, or the second one, or the third one?
If you want.
I want to study the temperature difference. Temperature difference and
The first one.
the thermal infrared shows you the temperature difference. So you have 3 satellites, A, B and C.
Very well. Switch it with this one.
So you thank you.
You
So you have the 3 satellites A, B and C. Okay. So
We will use it.
which one you will use? You will use A. He is telling he will use A. Which band you will use for the study the temperature?
The thermal.
The visible light or the near infrared or the thermal infrared?
Thermal.
The far infrared, or which we also call as thermal infrared. Thermal infrared you will use to study the difference in the temperature of the land surface. Okay. Now he says that we will use satellite A to study the temperature difference on the land surface. So why did he say? Okay, why did you say A? Explain it.
Because we have 3 bands in the thermal.
So this bands refers to what?
The more
Spatial
bands-
resolution or temporal or spectral? Band refers to spectral resolution. So that means it has 3 bands. That means it has a higher spectral resolution in the thermal region. So I can better, if you look at satellite, the third one, there are no bands in the thermal infrared region. So I cannot use to study the differences in the land temperature using satellite number 3. But here, because there are more bands, I can use it for studying the differences in the land temperature. Okay, so this is an example how you need, or for example, someone is interested in seeing the type of trees which are there in a forest. Will the forest have only one type of tree, or will there be different type of trees? There can be different types of trees. What is the color of the leaves in the tree? Green. All the green are the same color, or they may be of different color. Various different shades of green will be there. So, in that case, if you instead of multispectral, now we have images which are hyperspectral. That means instead of 10 bands or 15 bands, you have hundreds of bands. So, for example, you have, say, this is the green color, say, which is between 0.5 micrometers to 0.6 micrometers. Okay, this is the wavelength for the green color. Okay, ideally you will have only one band in this color. So if there is one band, one color, so you will see only green. One green color you will see. Okay, but nowadays in the same band, in the same region, you can have, suppose there are 10 bands. So for very, very small wavelengths of green color, you will have a different band. So if there is slight change in the color of the green, you can easily identify that. So
contrast.
The contrast. So even for mineral exploration, like you have the rocks, granite may be appearing similar to basalt, or a basalt may appear similar to andesite or granodiorite or any other. So there may be only slight differences. If you have an image with a low spectral resolution, you may not be able to differentiate. But if between the two different types of rocks, but if you have a very high spectral resolution image, means you have different bands, then changing the band combination, you can identify those different minerals. So mineral exploration, in mineral exploration, if you asked an example, so okay, mineral exploration, we need hyperspectral images. What are hyperspectral images? Very high number of bands. Hyperspectral means not like 10 or 12 or 13, no, more, 50, 100, 200 bands in the whole image. So
small bands, that means more range of the color.
More range of the color, more easy to means highlight the slight differences in the different minerals in the different rocks. Yes, more range. More range of color will also be affected by the radiometric resolution. But if two satellites, they have images have the same radiometric resolution, then the one which has more number of bands, that will be better to see the differences. Which has more number of higher spectral resolution, that will be easier to identify the different minerals or the different trees. Okay, so in mineral exploration, we need bands with images with high spectral. Of course, you need spatial resolution also, but other than the spatial resolution, you also need high spectral resolution. Okay, so we discussed all this. Okay, this we saw, like this temporal resolution. Land use, land cover, you do not require images with high high temporal resolution. You will see for this city, you have one image from 1973, the other one from 2000, next one from 2006, and you can see how the city area has expanded over time, how the city has increased in area as the time progresses. So you can see the changes in land use, land cover, using an image which has a low temporal resolution, but of course you need a high spatial resolution because you want to see the features which are there on the surface. Okay. But on the other hand, if you have to study the Weather pattern you don't study over a small city or a small region. You are covering a larger area. For example, here it is covering almost the whole of Europe. Okay, it's a very big area it is showing, but that means you do not need a very high spatial resolution, but what you need is a high temporal resolution. You have 4 images over here, 1, 2, 3 and 4, and the time gap between these 4 images is half an hour. This is from all images are separated by half an hour, so it means you should have a very high temporal resolution because the weather it changes very quickly. You see yesterday all of a sudden it became windy at night. In the morning now the weather is not very cold today, it's okay. So that means it changes with time very quickly. So if you have to monitor something which is changing very quickly with time, for that thing you need an image which has a high temporal resolution. Okay. Then coming to the last type of resolution, which is, okay, here you have a graph which, okay, this is not very accurate, but still for your understanding, on the y-axis, on this axis you have the temporal resolution, on the x-axis you have the spatial resolution. Now tell me which satellite has the lowest spatial resolution. These are the names of the satellite. Okay, Spot. This is Landsat. Landsat again. This is MODIS, Aviator,
Meteosat.
and Meteosat. Which has the lowest spatial resolution?
Meteosat.
Spot has the lowest spatial resolution. He is saying Meteosat. Spot spatial resolution is given on the x-axis. Spot, if you see, it has a spatial resolution between 10 meters and 30 meters according to this image. What about Meteosat? Meteosat has a spatial resolution of around, say, something between 2 kilometers and 3 kilometers. So which has a low spatial resolution? Meteosat or Spot? Meteosat, the pixel size is huge, it is 2 kilometers almost. So the very big pixel size. You cannot see anything, it has a very low spatial resolution. But what about the temporal resolution? Which satellite has the highest temporal resolution? Meteosat. You see here, if you extend this on the on the y-axis, you see it is less than 1 day. Less than 1 day means it is a few hours. So what kind of satellite do you think will be Meteosat? Land observation or weather?
No, we don't.
And why do you say it is weather?
Because
Very high?
very high.
Very high what? Spatial or temporal?
No.
The temporal resolution is very high and the spatial resolution is low. Normally for a weather satellite, that is the requirement. You do not require an image with a high spatial resolution, but you require an image which has a high temporal resolution. Okay, so Meteosat normally it will fall under the category of, it is a weather monitoring satellite. Okay, and what do you think about Spot? Which kind of satellite it will be? For land observation or for weather observation?
Land.
Land observation. Why you say land observation?
Because it's on month, one pictures and very high resolution.
Very high, but now you have to specify which resolution. Spatial or
Spatial.
spatial resolution is very high. It's less than 30 meters. That means you can very clearly see the things which are there on the land surface. So Spot is used for land observation. And if I ask you about the orbit, where do you think Meteosat will be placed? In the GEO or MEO or LEO?
New.
Well,
Leo.
GEO,
for which one?
For
MEO, or and LEO. I am asking Meteosat will be placed in which orbit? GEO or MEO or LEO?
Leo.
Because we need to cover
No,
the
all
whole area.
new.
But give me an explanation why it will be.
Because we use meter.
Only
We need to
because
cover
of
the whole
that?
area. To see whole area.
Weather is there, but what is the speciality for the weather satellite? You need images with high
Oh, geo.
temporal resolution. So in the geostationary means the satellite. I am the satellite and I am continuously looking at you. So I can take as many pictures, images as you want. Maybe every 1 second also I can take a picture. Why? Because I am continuously
You want,
looking at you.
Very long distance.
So it's at long distance, and moreover it is
To cover
placed
more
in
area.
the area is more, and moreover it is in the geostationary orbit. If the satellite is in the geostationary orbit, that means its position in the sky will be fixed with your position. So the satellite will be continuously looking at the same place. So that means it can take images with very high temporal resolution. So Meteosat will be placed in the geostationary orbit. What about SPOT?
Geo.
SPOT or sorry, any Earth observation satellite, it will be placed in the LEO, low Earth orbit. Okay, because low Earth orbit is closer to the Earth's surface, between 500 to 1200 kilometers. So if it is closer to the Earth's surface, you can see the things on the ground more clearly as compared to MEO or GEO. Okay, so SPOT or in fact this Landsat, MODIS, AVHRR, they are all placed in the low Earth orbit. GEO is, the Meteosat is only in the GEO. Now what about, I said they are either in the GEO or in the LEO. What about the MEO? Why did
For
you just
GPS.
MEO? Huh?
GPS.
GEO is only for the GPS. It is only for the navigation satellite. It can be GPS, it can be GLONASS, it can be Galileo. All the navigation satellites, they are placed in the middle Earth orbit. Then the last type of resolution is the radiometric resolution. Radiometric resolution of an imaging system describes its ability to discriminate or differentiate very slight differences in the energy. Energy relates to the color. Okay? So the finer the radiometric resolution of a sensor, the more sensitive it is to detecting small differences in reflected or emitted energy. In classifying an images, different classes can be more precisely defined if the radiometric resolution is high. And radiometric resolution, how it is given? It is defined in terms of bits and given as 2 to the power n, where n is equal to number of bits. So suppose I say the image is a 1-bit image. So how many it will be? 1-bit image will be 2 to the power 1. So 2 to the power 1 is how much? It is 2. So how many colors you will see? Only 2 colors you will see. Okay, if it is a 1-bit image, you will see only 2 colors. If it is a 2-bit image, how many colors will you see? In 2-bit image, 2 to the power 2. So you will see how many? You will see 4 colors. Okay. So if the number of bits are lower, then you cannot differentiate between the different colors which you see on the image. If you see here, for example, okay. Now this is how things will appear in a 1-bit image. Like in the last class also I gave you an example. All of you are wearing this thobe. Some of the colors are not the same. Slight difference is there in the color. But if I use a 2-bit image to make the differentiation, all the dark color will come under black, all the light color will come under white. There will be no color in between. Okay? Either black or white, because I can see only 2 colors here. But as I increase the number of bits, for example in 2-bit I am seeing 4 colors. In 3-bit it will be 4 to the 8 colors will be there. In 4-bit it is 16. 5 bits 32, 8 bits you are seeing 256 colors. So means now you can see, you can differentiate between the colors. You can have something else completely black, then light black, you can have grey, off-white, and lightly white and completely white. Means you have the different range of colors. So normally these days the satellite images, they are mostly like 16-bit. 16-bit is how much? 2 to the power 16. So 2 to the power 16 will be how much? 65,000 something colors will be there. You see? 65,536 different colors you can identify. So even the slight difference in the variation, like for example this table, if you see from a distance, if you look, it is appearing as what color you will say, brown or yellow, whatever it is. Light yellow, okay. But if you go close, there are some bands are there inside, some shades are there. Now, if it is a low bit image, you cannot see that bands which are there on the table. But if it is a high bit image, more number of colors, that image, in that image, you can differentiate between the bands also. You can see the different things, different colors which are there on the table. So that means if the radiometric resolution is high, then you can see more number of colors in the image, and that makes your identification, task of identification easy. Okay, so with this we come to the end of the types of resolution which we have for a remote sensing image. There are 4 different types of resolution: spatial resolution, temporal resolution, spectral resolution, and the last one is the radiometric resolution. Then we will talk about the types of sensors. Okay. Now the first one, which was there on the Landsat satellite, okay, it is a multispectral scanner. Okay. Now it's not a we don't call it a multispectral imager or multispectral camera. It is a multispectral scanner. When we talk about a multispectral camera, when we use the word camera, then we are talking about a lens. A camera has a lens through which the light will pass and it will be recorded on the whatever in the digital form. But when we say scanner, have you scanned a document anytime using a scanner?
Yes.
So how does it scan? Is it scan at once, or is it scans in slowly, part by part? Slowly. So you have, like, you can hear the noise and the scanner, the ribbon, it goes to and fro and it scans the image. So same principle is for the multispectral scanner. It scans the area. It does not take a image of the picture, image of the area like a lens. It scans the area and then it generates the image. And here you see it is written as multispectral. So that means in different spectral bands it can scan and get the image at the same time. For example, Landsat has say 13 bands, okay, and say in the visible region of the electromagnetic spectrum there are 3 bands, for example. Sorry, Landsat has 11 bands. In the visible region there are 3 bands. One for red, one for green, one for blue. So it's not that it will scan one time and it will acquire an image in the red band, and then the second time it will scan and it will acquire an image in the green band and then in the blue band and so on. No, it will scan once, and in the same scan it will scan the images in different spectral bands. So all the 11 bands, they will be scanned or obtained at the same time. So in one scanning it can obtain images in different spectral regions. So that is why the name is multispectral scanning, MSS. So this is a type of scanner, a scanning system which is used to collect data over a variety of different wavelength ranges is called a multispectral scanner, and this is one of the most commonly used scanning systems. It is taking images over a different range of wavelengths of the electromagnetic spectrum, and all those images are acquired at the same time. So that is why it is called as a multispectral scanner. Now when you talk about multispectral scanners, there are 2 types of multispectral scanner: a cross track and a long track. Now there is slight variation in the 2 types of scanning system. Now your satellite, say, is moving in this direction. You have the sensor to which that multispectral scanner is attached. If the satellite is moving like this and the scanning is perpendicular to the satellite, if the satellite, say, is moving like this and the scanning is done in this direction. So it is cutting the path. It is a cross track. This kind of scanning, it is also called as a cross track scanner. As you can see here, these are the scan lines, different scan lines, okay? And the direction in which the satellite is moving is this. So it is cutting the scan line. The direction of scan and the direction in which the satellite is moving, it is across, it is perpendicular. So that is why this is called as a cross track scanner. In sometimes it is also known as the whisk broom scanner. Means you have this broom called a whisk broom, this shape. You just, if you have to clean the house, you hold the broom in your hand and you do like this, and you are moving forward. So you are cleaning like this and you are moving like this. So you are, means the cleaning direction is this, and the movement direction is across. So that is why it is same way the cross track scanner works. So sometimes it is also called as a whisk broom scanner or a cross track scanner. Huh? Whisk broom, the thing which you use for cleaning. Broom. What do you call that thing? Broom. Huh?
Vacuum.
No, not vacuum, not vacuum. Vacuum is electric. The manual thing which these people are using for cleaning. Yes, so that's the broom. So you can have two types of broom. Normally the broom which you see here is this kind. This is called a push broom. This is a long track scanning, and if you look at this in this one, the direction in which the image is being scanned and the direction in which the satellite is moving, they are the same. They are parallel to each other. Means the satellite is moving in this direction and the scanning of the Earth's surface is also in the same direction. So means it's like this here. Okay. So this is a long track scanner, or sometimes you also call it as the push broom scanner. You have this kind of broom, you hold it in your hand and you just push it and you move forward. Okay. So this one is a push broom scanner. So a long track scanner, also known as push broom, and the cross track scanner, that is known as a cross track. Okay. A cross track. So this is known as the whisk broom. Whisk broom. Across means the scanning is like this, okay, and the movement of the satellite is like this. So it is the movement of the satellite and the movement and the scan lines, they are cutting each other. So that is why it is called as a cross track scanner. In the long track scanner, the scanning is like this, and the movement of the satellite is also in the same direction. Or if the scanning is like this, the satellite is also moving in the same direction. So this is a cross track scanner, and this one is a long track scanner. So these are the two main types of multispectral scanners. Then you have thermal imaging. Now thermal imaging, as you know, it is done in the long wave infrared region of the electromagnetic spectrum, which we also call as the thermal infrared. That means the infrared region, it can be divided into the near infrared, okay, the short wave infrared, the medium wave infrared, and the long wave infrared. So when we are talking about thermal imaging or thermal scanning, we are talking about the long images which are acquired in the long wave infrared region of the electromagnetic spectrum. So thermal sensors essentially measure the surface temperature and thermal properties of the target. Target will be the object you are interested in observing on the land surface. It can be a water body, it can be a farm, it can be a rock outcrop, it can be a forest, whatever object which you are interested in observing on the land surface, that is your target. And in thermal imaging, basically you measure the surface temperature of your target. Now these are some images, thermal images. Now for example, in this one, okay, The blue ones, the blue colors are showing the low temperature, and the red ones are showing the high temperature. Okay. So if I ask you just a question that where do you think most of the industrial area is situated in this image? The industrial area where you have the factories and
On the right side.
okay, you have means you can make a line like this. Okay, so this is left and this is right. So where you think is the industrial area? Right. And why do you think that it is in the right?
Have more heat.
More heat because of the factories, machines are there, they are continuously working, and because of that heat is generated. So the land surface temperature is more on the right side as compared to the left side. Also here you see, okay, there is a difference, okay. This is land and this is water.
Sea.
Or yes, okay, sea. So sea, red is indicating warmer, blue is indicating cooler. So which one is hotter here? The land is cooler or the sea is cooler?
Land is cool.
Land is cooler, means the sea is hotter or sea is warmer as compared to the land. Land has a lower temperature. So with the thermal images, you basically what you do, you find out the temperature difference. So this you can do even at the night time, because long wave infrared are not reflected infrared, they are emitted infrared. The radiation which is coming out from the earth surface, it absorbs the heat and then it releases that heat in the form of long wave infrared, and that long wave infrared radiations, they are recorded by the sensors. Now, do you think you can detect a forest fire at night using thermal images?
Yes.
Yes, at night also you can do that?
No.
Why?
No, in the night it will be clear.
Thermal scanner not means there is some cloud cover, but using the thermal scanner you can. Even if you don't see the fire, maybe the fire is the forest is dense, there is fire somewhere in the lower region. So because of the abnormal heat, if there is a fire, there will be high heat. The temperature will be high. So
You will see a red spot in the.
and yes, that means some area means you have an area and then you will see anomalously, like say high temperature in between. So how do you have the high temperature? So the possible reason could be there is a fire going on in the forest. So because of that, the temperature is high. So basically the thermal scanner, the thermal sensors, they help you in identifying the differences in the temperature on the earth's surface between different things on the land or between land and water. Here it's on the land, but based on the temperature difference, you could identify where are the houses and where are the industrial area. In the industrial area, the temperature will be higher as compared to the residential areas which are cooler. If you have suppose a park in the area, in the park the temperature will be high or low as compared to residential area. Houses are there and you have a park next to your house.
No.
In the house.
In the-
In the house it will be hot.
The power will
Yes, in the park it will be lower. You go to in the summer season, you go out in the park where you have grass. You will feel park will be warmer, cooler, not hotter. House will be hotter. If you walk on the road and you walk in the park, which will be hotter? No, not parking. I am talking about Hadika. Okay, so no, not the park like this one. Of course, this park will be, that is parking. So that's it. It will be hotter, of course. But when you go, say you go to Nakhil Park there behind, so it has a lot of grass, trees are there. So if you have grass, vegetation, trees, it will be cooler at night as compared to the landscape. Okay, so this is clear. So now we will, in the next class, we will talk about camera and some idea about photography. All of you are in